Thank you, Nandanji. So, myself, Dr. A.K. Sinha from Central Road Research Institute, New Delhi. I am working there as a senior principal scientist in Geotechnical Engineering Department. So, here I am going to present a recycle of red mud waste materials for sustainable road construction. Red mud is coming from aluminum industries as a byproduct, or we can say as a waste materials. So, linear economy or circular economy, I have defined here in constant of metal industries, not as a whole horizon. So here, linear economy means we have to produce, we have to use, and then just you have to dump or dispose. So we have to think about circular economy. Why we have to think about the circular economy? If you will see, now you will see in the world globally or even in India, different metals like zinc, chromium, steel, aluminum, copper, all are increasing day by day demand. So we have to explore different mines, and now what happens, raw materials, different ores are depleting very fast, and we are not getting high grade of deposit of different mines. And all these mines, ores are available under the ground. Either we have to explore through open pit or through underground mining. So high energy is required to take the ores from the underground. And nowadays, earlier we are not able to concentrate on environmental point of view. So now it is very crucial regarding environmental issues. So disposal of waste materials are very concerned regarding the environmentalist. And apart from that, huge quantity of waste materials are coming from the different industries, and we have a scarcity of disposal lands. So all these, so here regarding basic principles of circular economy in context of metal industries, if you will see, I am giving you one example regarding red mud only. So if you will see, red mud is a waste materials coming from the aluminum industry. That red mud is a waste. At present it is a waste, but if you will see, still red mud has valuable contents of different metals. So we have to explore the possibility how to extract elements from the waste material, from the red mud only. So mining of primary source of ores, which is under the ground, huge quantity of energy is required. But when we will extract from the red mud as a metal, different metals, less energy is required. So if you will see, apart from that, red mud is a waste materials, but having better engineering properties than soil. So it can be used as a construction materials, or it can be used as a structural fill materials. So based on that, we have studied the red mud for utilization in road construction. So these are the waste materials coming from the mining waste, like overburden or tailing, or different type of industries, jarosite, jarofix, zinc slag are coming from the zinc industries. A steel slag is coming from the steel industries. Pond ash, fly ash, bottom ash, cinder, all are coming from the thermal power station. Copper slag is coming from the copper industries. Phosphogypsum is coming from the fertilizer industries, and kimberlite is coming from the diamond industries, and red mud already we have told you. Manganese, chromium, chrome slag is coming from the chromium industries. Foundry sand is a natural material, natural sand, but it is coming from the molding industries, plastic, or we are knowing, and marble disc is coming from the marble industries, and it is concentrated in Rajasthan only. 90% marble slurry, marble dust is coming from the Rajasthan only. So all these waste materials have been explored for possible application in road construction by Central Road Research Institute. So we have mentioned here all waste materials which has been carried out in CRRI. So regarding red mud application, you see, any waste materials when we are going to use in the construction of road, it takes around 5 to 6 years. So in that first phase, we have to explore the engineering properties of that. In the first phase, we have studied in the laboratory. In the second phase, we have studied in the field in actual condition. In the laboratory, we have examined the physical, chemical, geotechnical characterization. Sometimes some of the materials has little bit properties less than as per the guidelines. So we have to improve the properties by blending with other good materials or by blending with cement also. So all these parameters we have to calculate, we have to determine in the lab, and in the lab also we have to physically, we have to examine the performance of that. And after performance examination in the lab, we have to numerically or analytically, we have to validate with that parameters. And then we have to develop a guidelines for application of these waste materials. Next is pilot study. In the field, actual field study, we have to monitor, we have, you see, all guidelines pertaining to defined or developed pertaining to soil or conventional materials. Earlier, we are not thinking about these waste materials can be utilized. So there is no any guidelines how to use, how much property is required. So we have to develop such a specification regarding different waste materials. So we have to construct a road using that waste materials, and then we have to train the site engineers, stakeholders, engineers from the PWD, engineers from the state PWD, CPWD, contractor, concessionaires, all stakeholders, we have to train them. And then during the construction, random check, you see, CRI cannot do hold the test. So random test we have carried out during the construction. And then during the construction, stress, strain behavior, all parameters we have to examine. And then we have to develop the construction methodology for a typical waste materials, and then after construction of that, payment performance we have to study for a long period, at least 2-3 years we have to perform, we have to study, and then economic, you see, without economics, no one will use any kind of waste materials. So we have to validate with economic analysis and environmental issues, environmental parameter also we have to studies, and then people will be convinced. After that, guidelines should be developed. So this is the, red mud. 1 ton aluminum, when we are going to produce, around 6 ton red mud will be produced. You see how much quantity, huge quantity we are generating as a waste materials, or already 100 million tons already deposited in the different industries. So if you will see whole South India, everywhere red mud is available. Bauxite ores are available. So we have studied red mud as a replacement of soil in the construction of embankment or subgrade materials. So this is the bauxite exploration we have taken from Raigad district, Odisha. And if you will see, next one is bauxite ore deposit. If you will see, it is just like a soil materials. So this is the deposit of yard of red mud at Raigad district. And this study was sponsored by Birla Industries as well as Vedanta Resources, and jointly CSIR CRRI, CSIR IMTT, NHEI, HG Infra Consultant was involved to study these waste materials in actual condition as well as in the lab also. So any waste materials when we are going to use in the construction industries, first of all, we have to examine that it is hazardous or it is non-hazardous. So TCLP test we have to carry it out, and all parameters, all metal concentration should be within permissible limits as defined by the Ministry of Forest Climate Change guidelines. So these are the permissible and these are the result, and it was found that it is a non-hazardous material because all concentration elements are within the permissible limit as per the Ministry of Guidelines. So now after that, when we are knowing that it is a non-hazardous materials, geotechnical parameters applicable for embankment construction, applicable for subgrade construction, parameters were evaluated and parameters were compared with other established materials. And it was found that properties of this material is similar to conventional materials like soil or sand materials. So these are the other properties. You will see in the tabular form properties pertaining to embankment construction, pertaining to subgrade construction, it is given here. So in laboratory also, physical model test was carried out to determine the different parameters in the lab. Another view of the another parameter CBR was determined by DCPT test. And then after getting all parameters, stability analysis of embankment was carried out in different condition, in seismic condition or as well as static condition. And it was found that factor of safety under seismic, under earthquake condition and static condition within the permissible limit. We are getting factor of safety more than 1, which is required as per the IRC 75 guidelines. So in the field, 3 sections were laid down. One section was control section, where all parameters, embankment, subgrade, all these parameters were constructed by using soil and aggregate. In second section, embankment was constructed with red mud and mixed with fly ash, and another one subgrade was constructed by red mud, which is indicated by the red ink. So details of project was in the plant, Rayagada district, red mud was taken. Site was Koraput, Odisha, and this site belongs to Raipur-Visakhapatnam Economic Corridor, which is National Highway 130. So this is the location of industries as well as site. And you know, at 290 Chanes, there is a flyovers. Because we are using first time as a pilot study, so in main line it was not permissible. So in the loop line, 3 sections were laid down. So in the green section, if you will see, in the green section loop line, in the green section, this section, 3 sections were laid down. So these are the details of the experiment. And this is the existing ground where construction was carried out. Another view of that at initial stage. And this is the construction progress using red mud. This is for safety purpose, even it is non-hazardous, but if you will see, to convince the people, both sides, cover soil, natural soil was used to safeguard the, and you see what happened, you see in Odisha coastal area, heavy rain was there. So it is a less permeable materials. So you see during the rainy season, it got flooded. So what we have to do, what we have done, we have mixed with fly ash, which is totally dry, and it is a permeable material. It is a fine grain, but it is a permeable material. So it was decided that fly ash will be mixed during the construction. So these are the photographs, and this is the another photographs of that. To examine the actual condition leachability, perforated HDP pipe wrapped with geotextile was used under the embankment. So this is the pictorial view of the line. This is the line diagram of leachate collection. And this is the complete compacted layer of embankment and subgrade. And 3 sections during the construction, different equipment was used to examine the quality of construction, like DCPT test. So if you see, sand replacement was used to determine the degree of compaction, and it was found that it is meeting the requirement of that. Quality control was carried out by DCPT also. Quality control was carried out by LWD, lightweight deflectometer test, and it was found that performance of red mud is better than embankment soil. Plate load test was also carried out to examine the modulus of the red mud material in comparison to soil materials. And now, during the construction, it was completed. This is the pictorial view of the completed roads. Signboard is also applicable here. Pavement performance was carried out by measuring deflection, by measuring roughness, and it was found life cycle assessment was also carried out in comparison to soil and red mud. Pavement economic analysis was also carried out, and it was found that 25% can be saved by using red mud. And these are the conclusions of this. It is a fine grained material. It meets the requirement as a embankment material or as a structural fill materials. Most of the properties are better than soil properties, and deflection, roughness, performance are better than conventional materials. And these are the references. From this, we can say thank you all for hearing me.